So hello everyone. Since my last post, many of you are having troubles or problems with arrays. So as for my first lesson, let's try to review what are arrays and how to use them. Now I will not be specifying any programming language in this class. That was for your first programming class. In my class, the programming language is not important. Instead, you need to be solving programming problems with the best and correct tool that you have learned on your CCC 100 class. So if you have a programming language preference, whether Java, C, C++, Python, or anything, just use it. Okay? Now that we got that out of the way, we go now to our lecture. So array is an important concept in computer programming, and array is a data structure that most often used to build complex or composite data structures like stacks and queues. In this lesson, we will talk about arrays, and we will see, using some programming constructs, what all different operations we can perform using arrays and how arrays are stored in a computer's memory. So we define an array as a collection or a systematic arrangement of objects of the same data type. And a typical definition or declaration of an array would look something like this. So an array definition will have a data type. In this case, we have an array of integers. And then we'll have the variable name. And we also have the size of the array. Now, where does this concept of array fit in programming? So let's say in a program we want to store the grades of 40 students in this class. Now in a program, to store these values, we can declare 40 different integer variables like G1, G2, G3, all the way to G40. So we kind of declare 40 different variable names corresponding to 40 students. Now let's say we want to calculate the average grade of all the students in this class. So to calculate, we will have to do something like a total of the grades. So we'll have a variable total, and this total will be equal to G1 plus G2 plus G3 and so on. And the total will be divided by 40 to get the average. But what if we have 500 students or even more? It would be very unmanageable to declare 500 variables and use them in our statements. So in this case, we can declare an array. So let's say we declare an array G with a size 40. And this array is a runner of integers. Now in this case, we also have 40 different variables, and I can access them as G0, G1, G2, and so on. We start at index 0 and we go all the way to index 39, and our program will be something like this. We again have a variable total, and this time we run a loop from 0 to 39, and we use the variable I as index and keep on adding gi to total, and finally calculate the average as before, which is total over 40. This was an array of integers. We can also have an array of float, or array of characters, or an array of user-defined class or structure. This was a simple one-dimensional array. We can also have an array of 2 dimensions or 3 dimensions. But let's see first on how arrays are stored in a computer memory. So let's say this figure is a computer's memory, which is divided into segments or partition. Each segment is 1 byte of memory. In fact, we are only showing a part of the memory in the form of these segments of or partitions. That is why it extends all the way to the left and to the right, because in reality, the memory will have many more bytes. In fact, a computer's memory is a very large array of bytes. Now, in computer's architecture, each byte of the memory has an address. So let's assume that on the leftmost part has an address 0. And as we move towards the right, we will increase the address to 1, 2, 3, and so on. So let's just say, for example, in this particular byte near the middle, we have an address of 100. And the next byte will have 101, and then 102, and then 103, and so on. In C and C++, we have a pointer variables that can store the address of another variable. Now, we can define an array something like an integer array. Let's say, for example, a size 4. Then, if an integer typically takes 4 bytes of memory, then an array of 4 integers will take 16 bytes of memory. When the program executes, the computer allocates 16 contiguous bytes in memory. For this array A, the computer allocates 4 contiguous blocks of 4 bytes each. So the first block or the first 4 bytes will correspond to A0, and the next 4 bytes or the next block will correspond to A1. Similarly, we have A2 and A3 as well. Now, to access an element in an array or its modification, all of this operation take constant amount of time. In other words, we can say that the time complexity for accessing or modifying an element in the array is big O of 1. Now, I hope you have learned about time complexities on your previous programming class. But just to review, time complexity is the computational complexity that describes the amount of computer time it takes to run an algorithm, commonly estimated by counting the number of elementary operations performed by the algorithm. It uses the big O notation because of the asymptomatic behavior of the complexity. Typically, big O of n, big O of n log n, big O of n alpha, and big O of 2n. So going back, how does this really happen? When we declare an array, like say for example, we have declared an array size 4, then this variable A is nothing but a pointer to the first element in the array. We can also say that the variable A is a pointer that points to the base address of the array, and this is better explained in a real program. So let's try to do that. We'll write a simple C program. I will declare an array A of size 4, an integer array. Here, A is nothing but a pointer for the first element in the array. So if we try to print using the printf statement, this should give me this. This is the base address or the address of the first element in the array. This should be the address of the first element, but how do we know this? Okay, we can try to print the value of the particular address. So to do that, let's add another printf. To print the value with a given address of a pointer variable points to, we put an asterisk in front of the pointer variable in C and C++. So asterisk A should give us the value of the base address, the value of the first element in the array. So asterisk A is the same as A0, or the first element of the array. Now let's see what we get. So we get an address, so the first line, and this address is different from the previous address because every time the program is run, the memory allocation will be different. But the second line is the value, which is kind of garbage, a negative number. This is happening because we have not yet initialized or filled our array with any data. So let's try to fill our array with data first. We can do that by filling our array with, let's say, A0 is 1, A1 is 3, A2 is 4, and A3 is 5. If we run this again, the first line will give us an address of the first element, and the second line will give us the value of the first element. So let's try to do that. Okay. So as you can see here, the first line is the address of the first element in the computer's memory. So, but the first element in the array is correct. A0 equals 1. Now let's try to do something here. Let's try to print A plus 1. And if you know the basics of pointer arithmetic, then A is a pointer to an integer, then A plus 1 should increment the address by 4 bytes, which is the size of the integer, and take us to the next integer. So a plus 1 should give us the address of the second element in the array, and whether this address is correct or not is something that we can verify by looking at the value of this particular address. So an asterisk of A plus 1 should be A1 of the second element in the array. So let's try to see the result of this. So the first line is the address of the first element, and as you can see, the second address, which is the address of the second element, is 4 more than the first. And we also got the values right. A0 is 1 and A1 is 3. So now it should be evident why accessing or modifying an element in an array takes constant time. When you try to access an element in the array, the computer first calculates the address of this particular element using the base address and offset. All this pointer arithmetic that we are doing here are possible only in C and C++. So if you're using a programming language like Java, you do not have the explicit pointer variables, but still the internal workings of how things happen in memory will be pretty similar. So this was the basics of arrays and how they are stored in a memory and how they are interpreted in a computer program. In the coming lessons, we will talk more about arrays and solve some problems using arrays. By the way, on our next lessons, I will just try to look for existing videos on the internet, because the internet has a vast source of lessons regarding our classes or our lectures. Instead of having to make my own, I think it would be best or better that I will just share to you the lessons or lectures that I am also viewing. This is because this is the first time that I will be teaching CCC 102. So at least while I am learning, you will also be learning, and we will be looking at the same videos that I found on the internet. Okay, so I hope that you understand, but I will try to be as responsive, and I will also try to be as interactive as possible during our problem solving activities. Okay, so thank you for watching.